Yeah, exactly.
An older fashioned way of this put a web drive over a longer like to like move it in the air basically. So what happens is that it evaporates the water on the rack and then the
Okay, everybody. Can you guys hear me okay? Cool. So you might notice that Professor Martin's not here. That's because he's out of town today. So I'm filling in. If you know me, I'm sure many of you probably know me. If you don't know me, my name's Libby. I'm a grad student in Professor Martin's lab, and I'll be doing the current weather for today. But to start things off, could we go to the weather challenge page? Me presenting the first half of Weather Watch means you're stuck with my spiel of the weather challenge. You've probably received an email about this. I sent it out, I think, early this week. But I operate the weather challenge also. And all this is every year, a large group of meteorologists, whether they're in academia or professionals or in the public sector, anywhere in between, come together every year and do a 2-semester-long forecast challenge, which is this. We participate in it also. A couple of classes here actually require you to participate in it. And all it is that every week a new city is picked for a 2-week period, and during that period you forecast the minimum and maximum temperatures, the maximum wind speeds, and then the amount of precipitation that you think that station will get every day in that 2-week span. And depending on how accurate you are or how close you are to what actuality is, you might be, rank higher and higher, and you can be the top forecaster in the country. Several people from this building have won actual awards from being the best forecasters for, multiple cities or even the entire year-long competition. So if you're interested in participating in this, I would recommend you do it. It is very fun. I enjoy it. It also looks really good on a resume for things if you're looking to work for like the National Weather Service or things like that. People across the entire country know what the weather challenge is. And it's a lot of fun because forecasting is fun. So check out my email if you'd like to sign up, or you can also come talk to me if you have any questions. The signups are due a week from now, so you still have time to figure that out if you would like to. So yeah, now we can get back to actual weather. We can just go back to the week-long goes east, if that works. So here's a week-long loop of satellite imagery from the goes east band 13. I'll just let it loop through as I kind of talk about it. If you're in 452, you've heard Professor Martin and I kind of harp about this a lot, but there's a very unactive pattern, I guess you could say, in nice terms for at least our portion of the U.S. and especially southern U.S. as well. Watching the loop, first off, as we get closer towards the end of the loop, you can see a couple disturbances off the western coast of Mexico. I believe as of now, most of those are unnamed. They haven't evolved into anything that is worth giving a name yet, but they're still worth to keep an eye on. Other than that, you can see there's essentially sporadic cloudiness kind of popping up in the central U.S., especially north central U.S., a few little disturbances here and there as we step through the week. For example, something I'll point out later is that you'll see once this restarts, a little blip of something kind of appears on coastal Virginia and North Carolina that a couple models thought would be a pretty big weather maker for them, but I don't believe it turned out to be anything too significant. What else?
Yeah, for that,
Yeah.
I guess they had gale and maybe storm warnings for southeastern Virginia, eastern North Carolina when that developed. I think it had sustained winds of about maybe 30 knots or whatever, but it wasn't a tropical system. I guess the biggest impact was maybe winds, rough surf, and heavy rain.
Okay, I say that's good to know because a couple places were slated to get upwards of 3-4 inches of rain within just a few hours, but I think most of the rain stayed either coastal or off of over the ocean. So that saved people a lot of flooding headache, which was ideal. But other than that, a really big thing of note, and then we'll talk about that more here in a second, is if we watch, especially towards the latter half of this loop, a really notable low pressure system forms off of the Hudson Bay and then moves kind of towards the Bering Sea off of the coast of Newfoundland and Labrador. And once we get there, I'll kind of highlight it a little bit. It is nearly the first blast of relatively cold air that they've seen so far this year. So while it's mostly been confined to upper layers, colder weather it will come eventually. We will get there one day. And then kind of watch, we've had relatively clear conditions, spotty clouds here in Wisconsin for the past week, which you can see is well reflected in here as we see clouds. Notable systems kind of almost reach us, but not quite give us anything of note. And so as we get closer to the step right now, you can see maybe stronger, thicker clouds moving this way, and that could kind of tease of what the rainfall might look like deeper into the forecast. For now, though, let's look at the radar and see if any of these clouds kind of centered over central U.S. or even off of the coast are producing any precipitation of note. And it looks like it is. A few spotty showers kind of centered over Minnesota, but also especially in northern Wisconsin and up to the UP. Some smaller spotty storms moving up towards our direction with, the low that is kind of centered in South Dakota, Iowa, Minnesota area. But a couple notable strong storm systems on either side of Arkansas. I know this morning a couple places in Arkansas and central Missouri saw some notable storms. I think there was actually a tornado warning, which I didn't expect to see. So yeah, kind of a lot going on. Other than the central U.S. though, kind of just spotty showers in a few different places. Southern Florida, where we usually see a lot of those spotty showers, they're already there popping up. And then over the southwestern U.S., especially kind of in the north half of California, just a bunch of spotty showers. But ultimately, anything close to something kind of a structured system is what is sitting over the central U.S., which we will see some of the effects of over the coming days. Okay. So now that we've kind of got the U.S. covered, can we look at goes west to see a glimpse of what might be going on in the Pacific, or maybe rather lack thereof?
You don't want to refer IR.
IR, please. Oh yeah, perfect. So here's the Central Pacific. Is this the, yes, it is the week long. Okay. Week long, once again, so last Friday until now. There's not a lot going on in the Pacific right now. If we don't count I believe that storm that formed here and this dissipated was Mario, I believe. Yeah. And then you can see the beginnings of one of the other tropical disturbances that are kind of hanging out off the coast of Mexico. Other than that, our ITCZ, which is all of these spotty kind of storms and convection popping up just south of Hawaii and across the whole map, it's also kind of hit or miss. We were talking about this in 452 discussion yesterday, where generally there's a bunch of spotty storms all over this ITCZ line. However, as we get closer and closer to like more recent times of the satellite loop, there forms a pretty noticeable gap in the convection in this area. Like right here, there's some south of Hawaii, but ultimately there's nothing of note really kind of forming in that band of the ITCZ, which is unusual, especially down at lower latitudes. Other than that, you can see a couple cloud bands moving off the up through the Pacific towards the Gulf of Alaska. There's one notable cyclone that developed. It kind of spun its way out. And then as we move closer to current time, you can see we're slowly but surely we're seeing the beginnings of something else notable that might form and maybe actually bring us a change to this kind of stagnant pattern that we in the southern half of North America have been stuck in for the past several days. So with that, can we look at current surface map observations? I'm sure you've all noticed it's been weirdly warm for the middle of September. mid 80s, almost kind of upper 80s some days even. And that is still about the story today. We're currently sitting at 78 degrees, so mid to late September. Not too bad if you like warmer weather. However, the rest of the country, seeing lots of similar things, especially the eastern half, where they're stuck under this high. We'll talk more about that here in a second. But with this high sitting there, especially the eastern half of the country, has seen clear skies all week, and then they've got temperatures in upper 80s, 87, 86, cresting 89 down in central Georgia and in the south. But it's also really dry in the eastern half of the U.S. So, we can pick anything. Here over Ohio, they've got over a 30-degree dew point depression. Lots of relatively really dry conditions over this half of the U.S. And with this pattern we've been in, where the high is just kind of hanging around, not really doing anything, there have been a couple spotty showers here and there, but no real precipitation of note that could really relieve any of this, atmospheric dryness, but also dryness at the surface, which I'll mention here in a second. Otherwise, you can see the low that is currently sitting out to our west that might bring us the rain that we're going to see kind of throughout the weekend. And then you can also see the cloud mass. Most of the U.S. is relatively cloud-free. Everybody's getting, relatively sunny skies, except for us in Madison, and the kind of central half of the U.S. is stuck in almost nearly or fully cloud cover. So a bit of a dreary day if you're stuck in the central north U.S. like we are. But speaking of the dry conditions, if we could go to the drought monitor really quickly. This is the drought monitor, as you might have guessed. It monitors just drought conditions for several different sectors all over the U.S. To see, if we scroll down a little bit, I think it has, the scale is right here. So in the lighter yellows or in light orange, you're maybe in it's maybe a little dry, or you're at a moderate drought. So a little closer to normal conditions, but as we get into the bright red and then the dark red, that is extreme and exceptional drought conditions. So I won't go to it now, but a lot of the eastern half of the country was stuck in, moderate to abnormally dry conditions, some severe in some places such as, the Boot Heel, Missouri, southern Illinois, that area, a couple weeks ago, or even just last week. However, with the presence of this high that stuck around, brought no rain, brought, bright, hot temperatures, clear skies, this has exacerbated the drought a notable amount, especially in the eastern half of the U.S. And if you kind of consider, it's late September, now is probably a pretty big agricultural time for a lot of people, especially, I know because I'm from around this area, but the Boot Heel of Missouri and the surrounding regions in Kentucky, Tennessee, Illinois are big on agriculture, especially moving into places such as Ohio, Indiana, Illinois, that band. Some of the Corn Belt exists in there, but big agricultural regions, and they're also dealing with a lot of drought right now.
Right, so you're saying this drought has persisted since over the last month or so, or has it gotten worse in the last month?
Both.
Okay.
It's kind of medium, moderate drought conditions to severe drought conditions existed the past week and the week before that. However, the week that we've had this high pressure system kind of sitting over everything has pushed these regions into extreme drought.
So I'm wondering if for the agricultural interest, for things like corn, I imagine that, sort of the peak growing period was probably up until the middle of last month,
Right.
middle of August, maybe late August. And so now that they're entering a time where they're harvesting, is this a good thing that it's relatively, at least for some
I don't know.
crops that are going to be
It might
harvested?
be, yeah. But anything that would be harvested maybe a little bit later would be
Yeah.
facing some issues. So definitely of note. And then I took a look at the drought conditions over the kind of western half of the U.S., and those have been hanging around for the nearly entirety of the summer. So this is nothing new to them at this point. Okay. With that, can we go to the super peats to kind of get a glimpse of what the upper levels have looked like over the past week's time span. Can we start at 250? If we do the loop for GFS, that works, and then I'll just have you like stop it and then slowly step through it as we kind of go through. So this is 250 millibars. Your kind of gray and purple shading are your wind speeds at this level, so essentially your jet stream wind speeds. Sorry, everybody's ears. Okay. Can everybody hear me still?
Yeah.
Okay, cool. Sorry. But this is where we were last Friday. Right now, at that point, there were any sign of a significantly strong jet stream was all confined to northern latitudes. And then the main feature was this kind of ridging pattern, which we'll see carried down through all levels. So I only mention it now because of that. But ridging kind of in the central US, troughs on either side, and then the only jet stream is confined to northern latitudes. If we skip forward a couple, we'll see this pattern kind of just hangs around. The jet stream evolves a little bit. It never ventures any very far south at all. It usually really hangs in the kind of around the Canadian border, and some of the states next to the Canadian border is about as south as it goes. Ridge trough pattern, still hanging out. By now, this is on Sunday, so that's 2 days from the future. If we keep going, however, things still hang around. By now, we're at this Wednesday, so just a couple days ago. You can start to see the beginning of the low that we will be dealing with here in a couple days, but still, the jet stream is still stuck at northern latitudes. And even as we move forward, what day is this? Wednesday? Let's step forward a couple more. Right here works, or go back one. Yeah. So this was yesterday at 12Z. Our jet is still in northern latitudes. However, wind speeds, keep in mind this is at 250 millibars. Wind speeds in the southern US are very weak for 250 millibars. Here in central Tennessee, there is a wind barb of 5 knots at 250 millibars. That is something I should be feeling on the street outside today, not at 250 millibars. It's weird. I don't know if I've seen that much before. And it's not an anomaly. Surrounding wind barbs are at 10 knots. That's blustery compared to everything else surrounding it. It's a very weak pattern that has just situated itself over the US, and it's kind of why we've seen relatively clear skies and warmer temperatures over the past few days. And then if we keep going to current time, so where we're at right now, we're still kind of in the same pattern. The jet is still stuck in northern latitudes. I'll talk about the cyclone forming off of Hudson Bay as we go to lower levels. However, a jet streak is looking like it wants to form off of the eastern coast, and then off of in the northern Pacific, there is still a notable jet stream, which you might talk about. That is going to reach a disturbance might bring us some weather in the coming week. So yeah, that's 250. If we step down to 500, it's a relatively similar pattern that we saw above, right? We still have that trough. At this point last week, us in Madison, we're stuck kind of right at the ridge crest, I mean to say. And then still, the only really height gradient or even really notable spots of baroclinicity are kind of still confined to northern latitudes. Here in the trough, in the western portion of the US, it wants to be, and we might see that if you step forward a couple. Yeah, things slowly begin to develop into what we'll see in the coming days. Winds here still relatively weak for being at 500. There is this little disturbance that kind of takes shape out in the Atlantic and then slowly moves in over coastal Virginia and North Carolina. That's the storm we mentioned earlier that Michael mentioned. It was very blustery, lots of winds. A good amount of rainfall fell over the ocean from this storm. It's kind of just a weird little disturbance. I don't know if you know anything specifics about it, or if it was just a little blip that happened to...
Didn't talk about it last Friday, although it was in the forecast.
Yeah.
It developed in just south of Cape Hatteras, sort of in that concave-shaped region off of Savannah, and that's probably due to the land-sea temperature contrast. And it spun up and then sort of drifted northward. Hurricane Center said nothing about it appropriately, so it didn't develop into anything that was named tropical, but I mean, for times it looked like it was...
the path it took almost looked a little tropical, so that's why I was asking, because I didn't know if it did anything that I just didn't realize, because I'm not a tropical person. But knowing that, this is Tuesday. If we keep stepping forward a little bit, most notable thing we really have is still the very weak, I guess you could call it, pattern that is sitting over most of the U.S. There is relatively very large lack of any form of height gradient when compared especially to this notable storm that forms over the Hudson Bay and moves, kind of is heading towards the Labrador Sea. But for us, it was a really, really calm week. Not a lot happened for us, especially in most of the U.S. So let's step down one more, because I think the storm over Labrador and Newfoundland looks a little more interesting. Yes, please. Sorry. So here's 850. Once again, starting where we were at last week at this point, you get a better look at the high that has kind of dominated the eastern half of the U.S. throughout the week. And as we step forward a little bit, it has been encouraging southwesterly flow, which is why we've been in kind of the mid-80s and these really warm temperatures, clear skies. And we'll see why that's kind of about to come to an end in the forecast. But still, it really persisted, hung around. You can see better the little blip that kind of moved in towards Virginia and North Carolina, and then relatively quickly disappears as we keep stepping through. And then could you step back a couple? That worked. Oh, one more forward. Perfect. So Thursday, blip is mostly gone. This low at 850 is at least closed off on itself and is slowly heading this way. But this storm over the Labrador Sea is very pretty. On satellite, you can see it's starting to get itself wrapped up, but while we're looking at heights and the temperature gradient, you can really see the thermal structure of this storm in these red dashed temperature contours, right? Where it kind of comes in and then juts down. We have our warm front and then our attached cold front. And you can also see that pattern in these small little dips in the height contours as well. So a very pretty storm, a very nearly textbook good for learning storm if you're trying to identify that on maps like these. And then we can just step forward to where we're at right now at this level. So yeah, the storm still chugging as of 12Z today, still prominent. The low slowly making its way toward us. You can see the winds are kind of almost nearly southerly around us. That's funneling up those storms we saw on the radar are heading our way. Some storms may come of that from later this afternoon into the weekend. And then one thing to keep in note, it'll be fun to keep an eye on for next week to see if this hangs around, is the disturbances that are kind of forming up off of the coast of Alaska, to see if they bring us anything of note that could change up this kind of stagnant pattern we've been stuck in for the past week or so. Other than that, that's about all I have for current weather. Does anybody have any questions or comments? Yeah?
I noticed that there were
multiple areas of cutoff lows. There's the one off the East Coast that you mentioned. Then the one that's been over the central part of the U.S. pretty much all week in some capacity. It was especially interesting when you saw the jet stream, like maybe 250 level, where probably it may have been even over like Northwest Territories and none of it, where the jet stream is there, and then way farther south of us, there's just a couple weak little cutoff lows. There's like kind of a weak ridge, and there's like nothing happening. Anyway, my question, I guess, for you, Dr. Morgan, maybe is like, why does it seem like the pattern over the last week is really encouraging the formation of cutoff lows over the continental U.S.?
Do you have a take? I think my biggest guess is that because the jet is so confined up to northern latitudes, it's hard for us to get anything of like a gradient or of really anything of note. And so any low that's going to form is going to be, I feel like relatively weaker or not be able to get as much oomph, I guess you could say, as the ones that form off of like Labrador Sea, where they've got all of that extra, baroclinicity, the gradient, et cetera, everything that's needed to help the storm actually kind of spur up. But
Yeah, I think, Libby's response is, I think, a decent one. It's not clear to me. The next question would then be, well, why is the jet so far to the north
Right.
this time, right? And that's, I don't know, I haven't really looked carefully at what would be the cause of that, but I would say that the consistency of most of the thermal gradients being concentrated to the north, it'll place the jet there. But I also kind of wonder what impact that has on the sort of the oddity that's going on over the Atlantic with the tropical cyclone season upland to this point. Are there links to that? I don't, it's not really clear to me. But this isn't, I would say, super unusual. I mean, the wavelength of the pattern that's sort of established itself over North America is pretty large, and so that would dictate that it's going to be slowly evolving if it's a sort of a Rossby wave-like pattern. And so just in a few days or within a week or so, maybe things are going to then kind of break down as this shifts, and we'll get into a much more active pattern, I imagine.
So that jet stream is going to play a part in that.
Right.
yes.
Yeah.
Okay, if I have no more questions, I'll turn it over to Professor Morgan for the forecast.
Thank you. Great job in terms of the setup for the discussion that's going to we'll sort of continue with. First, I'd like to go to the tropic.ssc.wis.edu site. So SSCC maintains, I get lots of sort of federal NOAA weather data, satellite data, and do the processing of it. And so I have a nice site that sort of looks at tropical cyclones all over the globe. And what we're going to focus on in the Atlantic, we do have at least one disturbance at this point. This is Gabrielle, formed a couple days ago. It was a sort of Cape Verde storm. Initially, it moved off the African coast, and it's been moving to the west, northwest, and now northwest. The current, you can see it's track from the time it was identified, then the forecast track going forward. It's expected to head very close to Bermuda over the weekend, and maybe close enough to give them tropical storm force winds. If we want to look at the current structure, we'll go to the visible satellite imagery on this 1 kilometer, and we'll loop it, and a GIF right there, so you can see the loop of this as a tropical storm. And I should have gotten the intensity that we can get either from this or from the Hurricane Center in a second. But you can see it's not the most impressive looking tropical cyclone that you've seen, certainly even as a tropical storm, with most of, at least in the early stages of this, of the circulation sort of not really covered by much deep convection. You can see areas of sort of overshooting cloud tops to the east and northeast of the cyclone, moving to the north of it. This position, actually, to the northeast of it, here's the cyclone center. And then to the southwest of the center, convection's beginning to develop. It's beginning to encroach on the cyclone center. And that's a sign, if you're looking for intensification to occur, because that's those deep convective turrets are gonna help produce vortex stretching, the bringing in of the vortex lines, and basically begin to help spin up the cyclone over time. Okay, but it's gonna take some time for that to ultimately occur, but this is maybe a condition. If the shear relaxes a little bit, that convection can creep even closer to the center and allow that to begin to spin up. Let's go back, not go back, but go to the IR imagery. There, and then this moves it back. We'll put on, I guess, the Hurricane Center's the colors for this. They have the different enhancements that they have for it. I saw this earlier. I don't see it right now. Yeah, IR and NHC. Thank you. And also add on top of it the GOES lightning mapper to get sort of lightning from space to see the detection of that relative to the center. We could have probably done that better on the close-up visible, but again, most of the lightning is in these big, deep convective torrids away from the center. Maybe a couple of flashes that have occurred closer to the center, indicating convection getting a little bit closer to that. But on the IR imagery, it looks a bit more impressive, right? But again, the key thing to remember is most of this convection here is not very close, directly over the center, and so that's going to sort of limit much in the way of intensification. And then here's again the projected track. And I wish we had, I don't use this site a lot, I haven't used it a lot recently because there's been not much to talk about, to see what there it is, the initial, at least the estimates that they have, about 1,003 hectopascal, and winds are just minimally at hurricane force, I guess, at least from the satellite estimates. Okay, so that's the track. Looks like at this point, it may just move to the east of Bermuda and then head back out into the Atlantic. We'll see the impacts on the forecast. If we could go to nhc.noaa.gov and look at the sort of a broader outlook for this. Thank you, Pete. So here's Gabrielle, but there is yet another disturbance that's forecast to develop off the Cabo Verde Islands here, and this is, as this moves out, it's expected to, there's a slight chance for it to develop as it moves to the west-northwest, but it's pretty small right now, at about 20%. We'll see in the forecast a little bit later on, and by the end of next week, another disturbance, I don't think it's necessarily this one, will be in the vicinity of the Bahamas, and maybe moving into the Gulf of Mexico. So it looks like the seasons can become a little bit more active, and so we'll watch that in the forecast. Let's go to kai.aos.wix.edu, and we'll go to the, there we go. So our local wharf model run. First, go down to the bottom, start off with the meteorograms. Again, forget the dew point. I haven't worked on that yet to fix that. Those dew points are ridiculous. Actually, they don't look bad, but I don't think they're right. This is Celsius, this is Fahrenheit. But that's what the title says. It doesn't say what the actual obs are, but that's, yeah, this is Celsius, temperature in degrees Celsius. Right, so here's the temperature, and as I like to say, 60-hour forecast. At least this model actually suggests we will have 60 hours of reality left at least. We don't know beyond because the model stops at 60 hours. But you can see temperature trend is going to be a little bit lower for tomorrow and maybe beginning to recover a bit for a high temperature on Sunday. But one of the big factors is going to be this, sort of periods of rainfall that are expected. This is the accumulated rain in green, maybe just over 3/4 of an inch expected from this particular simulation or this forecast. Whereas you can see sort of this rain is sort of punctuated in various periods of light to moderate rain. Last week was the first time we showed this for our current local wharf model run, giving us about 1/2 inch of precip. Starting, if you recall, we were talking about sometime between early morning and by mid-morning, about 1/2 inch. I think that's roughly what we got. About, at least in my house, I got 0.38. Storms came in around 4:30, 5 o'clock in the morning on Saturday, into Saturday afternoon when they finally ended. So we'll see how well this verifies. But again, sort of showery weather over the weekend. Temperatures a little bit more, sort of dampened perhaps by the clouds and precipitation. Let's go to the time height section, please. So our time height section, again, kind of a messy map, or a messy chart. In yellow, sort of in reference to things we were talking about today in 610, here's our isotropes. This is potential temperature every 3 degrees Kelvin. Plot it right here. We can see that in this entire diagram, potential temperature increases with height, so it's a stably stratified environment that we see there, at least for dry vertical displacements. You can see some places during the course of the early afternoon, we don't see the potential temperature varying that much with height. Here, even tomorrow afternoon as well, and that's suggestive of a neutral process where the theta is nearly constant with height. That's a neutral environment. So air parcels lifted are going to be left hanging there unless there's something to push them a little bit further. Also shown on this is relative humidity in red. Okay, and so we see relative humidity is getting above 90% during the period later on this afternoon. And in blue, solid contours here indicate upward motion. And so we can see these pulses again of upward motion that are occurring with the atmosphere nearly saturated. And that's going to be consistent with the development of some precipitation here. So we're looking for it to get a little bit, it's going to be damp with sort of these periodic showers. So what we'll next do is kind of look at the evolution of the surface maps and get a sense of how's this weather pattern evolving to produce this precipitation. Are there any features that are notable that suggest we're going to get, what's forcing the precipitation over the weekend, and then we'll kind of expand our view and look at a longer term forecast. So let's go to the maps, please, Pete. And we'll start at 6 hours in the forecast at the surface. As you can see, a fairly quiet and kind of uninteresting pattern as Libby was describing it earlier. Expected precipitation to our northwest. We saw that on the radar, so this kind of verifies fairly nicely. We did have a few showers earlier this morning that passed by, very light. I think it was around between 4 and 6 this morning. We had a very light sprinkle, but most of the precipitation is going to be well to our west and north over this time period. That surface cyclone we saw in the analysis kind of doesn't even show up here. The sea level pressure fields are pretty flat, 1,012 hectopascal right there. The more interesting weather, the colder weather, as Libby said, was that storm moving to Labrador Sea with thicknesses well below 528. This is probably rain and snow mix. We could probably go back to the surface map to see what the precip type is up there in far northern Canada or northeastern Canada. But that's where the cyclone's off the map. You'd say it's so exciting it's off the charts, but it's not there. Here we are sort of just waiting for the rain that's to our west. Other places to kind of look might be of interest, some convection out over the Bahamas and off the southeast coast of the United States, and then the western United States. If you recall, we saw that remnants of that tropical system that moved inland over parts of California. Some of this rainfall is from that event, that particular event. But again, it's not amounting to much. Let's go ahead to 12 hours in the forecast, so 18 hours, please. 6 and 12, 18. So here's the first bit of rain coming through by this late tonight, or early tonight, early tomorrow morning. Early in the calendar day, I guess is the best way to put it. There's the rainfall. And again, it has this pattern that it's sort of sweeping up from southwest to northeast up into, into Manitoba. The way I remember this is that's British Columbia there. This is A, this is S, this is M, Alberta, Saskatchewan, Manitoba. A synoptic map. That's how I remember my provinces in Canada. Do what you do, whatever works. So there's the precipitation here. And again, the flow is relatively weak, so this is just a slow-moving weather system that's going to persist. Let's go ahead another 12 hours to 30 hours in the forecast early afternoon tomorrow. Showers sort of continuing. Again, we saw from the meteorogram, it's not going to be continuous rainfall, but it'll be these periods of showers, at least expected by, in this particular forecast run. Thicknesses may be dropping a little bit, and that could be just from the ascent that we have over us, cooling things off a bit, but this is, again, not really exciting. There's not much to say about this. Let's go back to 850 hectopascal, and we'll go, let's say 12 hours in the forecast, somewhere halfway in between the times that we've been looking at. One thing that shows up that's kind of clear about this, and maybe gives us a clue to why we have this pattern of vertical motion or ascent and precipitation showing up in the forecast as well as the model, is if you look at this, there's warm advection occurring here, right? The air is blowing from warm to slightly cooler areas. It's somewhat localized, so that localized warm advection through here, I mean, the fill pattern isn't as intense here, and this isn't the strongest warm advection you're going to see because the thermal gradients aren't big. but it is somewhat localized here. In this region is where we'd expect to see the largest ascent occurring, largely because this is a region where we have localized warm advection. We know from the quasi-astrophic omega equation that localized warm advection favors ascent in this region. We talked about the stability. It's still stably stratified for dry displacements, but there is a lot of water vapor here, moisture, so this could help favor, if parcels are lifted sufficiently far up, there might be some small levels of instability. This could be favorable for precipitation and the showery type weather. So localized warm advection in this, and if we go to 700 millibars at this time, aside from the convective type precipitation, you can see this sort of broad band of ascent that occurs roughly in that zone. So there's a consistency there looking at the localized warm advection. If we go to 500 hectopascal at the same time, 12 hours, not the greatest PVA, potential positive vorticity advection here in the mid-troposphere. There is down shear of this broad trough that shows up here. There is some PVA, but because it's so filamented here, there's going to be a lot of cancellation. So we'd probably want to use another diagnostic to best identify that. But it's somewhat down shear of this region is where we might expect to see some ascent. All right, let's go to further into the forecast. We're at 30. Let's go to 42 hours. So Sunday morning, some of the heaviest precipitation has now moved off, or the accumulated precipitation has moved off to our east. And we know we still have some showers expected in the next 18 hours, even after this time period. We will do a loop in a moment. Some of that convection off the east coast of the United States is sort of wrapped up into another small cyclone just off of Cape Hatteras, but we'll look at other model runs to see how that actually manifests itself. And let's go to 60 hours, please. So at the end of this is going to be 0Z Sunday or Monday, so Sunday evening. Again, that slow-moving weather system has now moved mostly to our east. This is the sort of lingering last bits of precipitation during Sunday afternoon, expected just over us into over Lake Michigan and further east. And that brief spin-up of a cyclone is now sort of fallen apart out over the Atlantic. Again, if there's something folks want to look at, we can look at that, but this is, again, sort of the pattern that we have. Let's animate this. And thanks to Pete for getting these HTML loops that we can stop and start, save into all sorts of things. Again, not the greatest weekend for us in terms of just, you want bright blue skies and dry conditions. We're not going to get that. Looks like a lot of clouds and precipitation is going to persist over much of the Midwest, particularly from western Wisconsin eastward over this weekend. And this system that kind of briefly spins up and then dissipates out of the Atlantic, I don't think that's particularly interesting. It's not the weather system, not Gabrielle at all, and it's not what's expected to develop, at least in the models, later on this weekend. Later on next week. Okay, let's go from this to, let's go to just some of the local maps. We'll just take a couple ones. Let's go to tomorrow, 30 hours into the forecast. I'll work on the colors here, but you can see, here's Madison here with the, temperatures, at least in this forecast, 24 Celsius, which is what, about 73, 74 degrees, 75 degrees actually, Fahrenheit. So mid-70s perhaps for tomorrow with the showers around. Again, you can see from the map, it's not continuous precipitation over these. These are 3-hour accumulated precipitation amounts. And so it's not going to be rainy all the time, but we saw in the time height section, it's going to be somewhat sporadic. But you can look at that, again, just a view over the upper Midwest. And if we go to the end of the forecast at 60 hours at the surface, this one, just to get a sense of by sunset or near sunset on Sunday. You can see, again, bulk of the precipitation is to our east, and we have temperatures just around 70, I guess, by that time period. And if we step back and look at the total accumulated precip over the 60 hours within this forecast, right up here, you can certainly see the tracks of some of the convective systems, but just broadly, the pattern here, you can even see where the outline of the ridge here And it's interesting with this latent heating associated with the precipitation, some of that might be helping to reinforce the ridge that's over us. Which brings up another point. Let's go to the PV for a second. We haven't looked at this much so far this year. We'll look at the loop, maybe 315 to 325. So the variable being shown right here is the potential vorticity, airflow potential vorticity. This is a conserved dynamical variable, probably one of the most important for balanced, severely balanced motions in the atmosphere and in the ocean, but in the atmosphere, this context we're looking at right now. We're looking at it on an isentropic surface, or with an isentropic layer between 315 to 325 K. And this variable, as you may recall if you've seen this, is a variable, as I said, it should be conserved, which means if I know the PV at one instant in time, I know the wind direction, I know where that PV is going to go over time. And so the values that we see on here, on this, within this layer, should be just advected, transported around here. If you see PV increasing or see it decreasing, seeing purple areas beginning to emerge, a couple of places out here, that's indicative of diabatic heating that's occurring. So we can use PV as a tracer, and where it's not conserved, that's a sign that we have something dynamically or thermodynamically significantly occurring. Friction can also destroy it, but these levels were well above the surface, so well above the friction layer, so we wouldn't anticipate that to show up. And so during this animation, okay, we can see that trough feature that's manifested by a local maximum and potential vorticity moving by. We do see this one that's in the northwest flow intensifying a little bit. Maybe that's helping to kick things out. PV is also important because if you know its distribution locally, you can infer the dynamics of weather systems around it. Right? Local maximum PV are associated with cyclonic circulations. Beneath it, it's a little bit cooler. Above it, it's a little bit warmer, so you can actually track anomalous distributions of PV to say something about the weather, the evolution of the weather. The fact that we don't see strong gradients like this that are on the edge of this map, either here or coming into view on the west coast of the United States, is again indicative of the fact we're under this sort of broad subtropical regime with the jets well to the north. Gradients of PV are going to be tied to local jet maxima, large wind maxima, where we have strong gradients of potential vorticity. So we'll look at this a bit more again later this semester. Let's go from this and briefly go to, let's go to Pivotal and look at another quick view for the weekend and then expand out to look at the evolution of some of the weather systems in the Atlantic. PIVO should get us there. There we go. And we'll go to models, and we'll go to GFS. And if we were to just quickly get into 0Z tonight, so 12-hour forecast, and so this is the precipitation. This model has, again, these are 3-hour amounts, nothing over us in that last period, but again, you can get a sense of the showery-like precipitation. Are we going to hit every, is that WRF model forecast going to hit every single rain shower we're going to get? No, we're not going to expect that, but again, this is at least, the appearance of this is consistent with the forecast that we just looked at. Let's go ahead 3 hours into this at 15 hours just to see the progression of this. And so we're getting some rain, maybe a bit heavier showers after sunset tonight, and then another 18 hours, these showers persist. So the general complexion of the forecast is the same as what we saw, I'd argue, in the WRF model. Now let's step ahead to 60 hours in the forecast. And this looks to show the precip moving out a little bit faster, right, than we saw in the WRF model. But there's still some more lined up just to our west. Let's go to 72 and just sort of follow this. The big thing we're going to see over time is yet another anticyclone in central and eastern Canada pressing southward and eastward with our pressures beginning to rise as we move into midweek. Let's go to 96 hours, please. So 1012 was up here. Now 1012 was just to our south. I wish they did every 4 millibars. Kind of makes it look stronger than it really is. In any case, so clearing skies as that ridge begins to build in. 120 hours. Okay. So that's kind of suppressing lots of the weather, these weather systems to our south. Pressures have risen over much of southern Canada, upper Midwest, and so we have more of an easterly flow. So certainly areas along Lake Michigan are probably going to be a bit cooler than places a little bit further inland, but this looks like a fairly decent pattern. Big thing we've been talking about with dew points being kind of uncomfortable. Let's look at the dew points as forecast at 2 meters in this forecast. Still kind of high, but we're not in the 60s. Well, we're just on the edge of being in the 60s. Let's go ahead to 144 hours on this. Can we dry out a little bit? So we get into the 50s. So if this forecast is to be believed, we're going to get a bit more pleasant slowly over the course of the week, and the highest dew points remaining to our south, 168. So a week from today, things begin to dry up. If we go back to the surface map at this time, okay, part of that's because a cyclone's developed over or just to the south of us, so we're getting that drier advection moving in. Let's animate from this time forward, and sorry, go to forecast loop, but before you do that, just so we can get a better sense of the Atlantic, we can click on this first before you start the loop. Let's go to continental, click on that, and we'll go, yeah, this will be decent view. Forecast loop, and here's Gabrielle, and we'll just let this go forward. Okay, so we can see Gabrielle intensifying, moving to the northwest, and then finally north. And over us, you can also see the anticyclone beginning to build in to our north. Seems pretty quiet. That becomes a nice big storm east of Greenland. Gabrielle does. And we have some tropical waves moving eastward in the Atlantic. One that sort of pops up just southwest of the Bahamas, or southeast of the Bahamas, becomes a tropical storm, and then yet another cyclone ahead of it develops, and these kind of move out as the westerlies begin to impinge upon us. So that's one solution. Let's see how this compares with the ECWF solution. Same time. I don't know how far out the ECWF is. Not quite all the way out, but we'll animate this. ECWF doesn't seem to have as much in the way of heavy precipitation over us early in this period, but this is looping really quickly. And anything emerging in the tropics at this point? Other than that, that's about it, which is kind of interesting because the ECWF was a bit more active in the tropics from its 0Z forecast. If we go to the 0Z run for a second, Pete. And animating that. If I got this right, again, Gabrielle, that's off. Let's just watch down here in this part of the globe. And we'll begins to form a weak low here, and watch its progress. Heads through the Bahamas, through the Florida Straits, and becomes a fairly impressive hurricane in the Eastern Gulf. So models are kind of flipping and flopping with respect to the development of weather systems or tropical systems in the southwest Atlantic. We'll just see how that's going to go. But we have Gabrielle, and Bermuda, I guess, is the place to watch over the weekend, but it looks like it'll be a miss for that, at least at this point, in terms of a direct hit. So that's it for now. I don't want to go over too long. Again, thank you, Libby, for a great presentation, setting up the current weather. Thanks, Pete. And thank you all for your attention. Have a wonderful weekend.
Do the discussion, you know, Professor Martin and Professor Morgan usually do it every week, and that's a really high bar. But if you want to get some experience doing weather discussions, just let us know, and I'm sure they'd be happy to have a week off.
Right, and also if you see there's just one event that occurs during the week that you're really excited about, and you want to dig a little bit deeper into it, set it up and create a discussion around
Touch
that.
base with me or either of them, and be happy to have you present.